After watching the manufacturing process of the wind turbine main shaft, I finally understand why the price of a simple wind power generation equipment can reach tens of millions. An engine main shaft requires ultra-high specification metal, and manufacturing takes 3 days. The craftsmanship involved is comparable to that of military enterprises. Here in the local wind power manufacturing factory, the first step in manufacturing the turbine main shaft is workers first move this metal block weighing tens of tons to the workshop. Then, they divide the alloy steel in front of them horizontally and vertically and calculate the specific dimensions needed for this process. After the preparation work is completed, it's time for the cutting process. Due to the enormous metal volume, an automatic cutting machine is used. Workers only need to set the motion track, and the device can automatically divide the metal into 2 pieces, with the edges elegant and flawless. Next, it is transported to the furnace to heat the raw materials to a temperature of 1,200 degrees Celsius for over 2 hours until the furnace door opens, indicating the end of this heat treatment. However, this is not the time to rest. The metal needs to be quickly transported to the front by a mechanical vehicle, which seems insignificant compared to the massive metal. Still, from the perspective of the workers protected from head to toe nearby, this next step doesn't seem easy, especially when the metal workpiece comes into contact with the 2,000-ton stamping machine. At that moment, the surface oxide layer falls off with crackling sounds. If adequate protection is not in place, the terrifying sound of iron touching skin will echo throughout the factory. Next, the broken pressing disc is laid flat on the top of the metal workpiece. Under hydraulic pressure, the metal workpiece gradually becomes more rounded. Then, it is transported to the front again, entering the forging process. Forging is not just about obtaining the shape of the workpiece. Through mass pressure application, it can also eliminate defects such as casting looseness to a certain extent and improve the internal structure to enhance mechanical performance. After several rounds of forging, the square metal workpiece becomes a solid cylindrical shape. Then, the surface is repeatedly struck at high frequency until it becomes an entirely cylindrical steel, marking the end of the second pressing process. Next, a mechanical arm places it into the mold, aligning it for the final forging round. Under thousands of tons of pressure, the metal quickly adheres to the inner wall of the mold. With each successive pressing, the surface becomes more uniform. Once the character reaches the desired dimensions, it is slowly pushed out of the forging position. Then, the mold is removed, which requires repeated forceful downward impacts. After 5 rounds of processing, the large nail is finally pulled out. This is the initial shape of the wind turbine main shaft. It is then placed outside the workshop to cool naturally. After several hours of cooling, the electric furnace is opened again, and all the workpieces are pushed into the stove. This process is called tempering. Compared to ordinary workpieces, the tempering of these large pieces takes an exceptionally long time, lasting 24 hours in the furnace. Now, you see the iron cylinder before you after tempering and cooling. It's ready for machining. First, it is hoisted onto the lathe operating table. Then, using outer tools, a triangular chuck is firmly secured. The lathe is started, and the machine drives the metal to achieve semi-automatic turning. In the blink of an eye, the surface reveals the original color of the metal. Although this video is only a few seconds long, it takes over 3 hours to complete the machining in a genuine factory. The image shows the main shaft of the wind turbine. Do you know how heavy this solid iron cylinder is?